boys and girls, welcome back to your last video on functions. In this video, we're going to talk about linear functions versus nonlinear functions. So let's first talk about what the word linear might mean. If you look at the word linear, you'll see the word line, both with linear and nonlinear. So basically, the word linear means line, and the word nonlinear means not a line. So there's two different ways to determine if a function is linear and nonlinear. So a linear function shows a constant rate of change. So looking at our input values and our output values on this table, we can see that our input values are x increased by 3. So 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 3 is 12. Therefore, our output, 40 minus 8 is 32. 32 minus 8 is 24. 24 minus 8 is 16. So as x increases by 3, and y decreases by 8, the rate of change is constant, meaning it stays the same between both of our x values and our y values. So because of this, our function is linear. On a nonlinear function, the constant rate between the two is, or the rate between the two is not a constant rate. So looking at our x values, our input values is 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7. So our input values are our input values or x values are constant, but our y values, 2 plus 9 is 11, 11 plus 22 is 33, 33 plus 55 is 88. This here is not constant, meaning it doesn't stay the same. So as x increases by 2, y increases by different amounts. Therefore, the rate of change is not constant. So therefore, it is non-linear. Let's look at two more examples. In our x values, to get from 0 to 7, we can add 7. 7 to 14, add 7. 14 to 21, add 7. To go from 25 to 20, subtract 5. To go from 20 to 15, subtract 5. And 15 to 10, subtract 5. So as x increases by 7 and y decreases by 5, this is a linear function because the x is constant and the y is constant. Now let's look at our other table. Two plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. So our x values are constant. Now looking at our y values, 8 minus 4 is 4. 4 minus 4 is 0. 0 minus 4 is negative 4. So therefore, this function is also linear because the rate between the x is the same and the rate between the y is also the same. You could also tell by looking at a graph. A linear function has a graph that is a line. The graph is a line, so the function is what we call linear. If you look at this line here, it's a straight line, so therefore it is linear, and it's a linear function. A nonlinear function has a graph that is not a line. The graph is not a line, so therefore the function is nonlinear. So you can see the curve in the line, or in the graph, I'm sorry, so therefore it's not a line. Eventually you'll get to something called parabola, which is a fancy kind of term for some of these types of graphs. This example here is a linear function because it forms a line. This is nonlinear because the function is not a line. This is what we call a parabola. This is a nonlinear function because it does not form a line. Take a guess as to what you think this function is. Good job, it's linear. Take a guess as to what this function is. Good, nonlinear. Take a guess as to what this function is. Good, linear. Take a guess as to what this function is. Non-linear. And this last one here is a linear function because it forms a straight line. Okay, open up to your graphic organizer on linear versus nonlinear. Again, I have a representation in a visual form as well as a description of each. So a graph is a linear function if it forms a line. A graph has a nonlinear function if the graph is not a line. So this is a line. This is not a line. Again, this is what we call a parabola. And you can also tell by a function table. So a function table has a constant rate of change for both the input and the output. So my input values, -2, from 0 to -2, -2, from -2 to -4 is -2. So my input values have a constant rate. Let's look at my y values. From 3 to 6 is +3. From 6 to 9 is +3. And from 9 to 12 is +3. Let's look at our nonlinear function. So a function table does not have a constant rate of change for either the input and output. So let's look at our input values. From 4 to 8, I can add 4. 8 to 12, I can add 4. From 12 to 16, I can also add 4. To go from -3 to -5, I can subtract 2. From -5 to -10, I subtract 5. From -10 to -12, I subtract 2. This is not constant, even though there might be a pattern. The rate that it changes is not the same. It goes from -2 to -5, back down to -2. Even though our x values have a constant rate, the y values do not, so therefore this is a nonlinear function. All right, boys and girls, I will see you in class tomorrow, and make sure you come in with any questions or concerns that you might have about the video. All right, have a great night.